let me show you where you go to get these things. So if I just go to a browser and then go to YouTube, yeah, there you go. And I don't want to go to some place that okay, so DRFITG, okay, let's see what shows up. And I'm the one that looks like a square like that. So maybe I'll try to put some sort of funny picture or something there. If you go there, you'll see playlist. And do you see Find It Elements? It should be in there somewhere. Oh, there it is. It's the second one. So if I go to that playlist, what you see is day before yesterday, which is this Monday, this is Wednesdays, and then I'm going to do one today. There'll probably be one show up over the weekend, but then I'm going to continue to record the class from now. The beauty of what I've got is this is how it starts, but I can go in now and I can start this machine and it will go right back where I was. Unfortunately, it's doing the small screen, so I'll have to change so we'll have to let it's in the middle of, so this way it'll be somewhat seamless, although I have to remember there was no audio before. So I'm going to, the first part when this comes up, I'm going to explain a couple things. Or I could just start over if you wanted me to. I can just do a beam. You mean just do a beam? How about that? Here's what we'll do. New.
So this program is going to be on this.
Right. Right. And this thing, what we'll do, I'll tell you what, let's just do a save and close, and I will start over and just do a flat, straight, easy cantilevered beam. And the beauty of this is it's free, and they keep updating it, and there's a large company that supports it. So although you don't have somebody you can call on the telephone, there are countless people all around the world who use this, and so you can get on one of those sites where you communicate with each other, kind of like a Facebook thing for this, and ask questions, and usually what you'll find out is they'll answer within a couple hours. You know, you'll get some guy from India answering, and then some other guy from France, and so they are pretty active on this piece of code. And actually, you can see that if you look at my YouTube channel and look at the most watched videos. They're all dealing with Salome, this software. That's where they're looking at most. Of course, the first country is United States. The second is France. So your first thing, you got the same process across this top right here. In other words, I'll draw it down and point to it with my finger. You've got, so this comes up here. Let me do this. Since there is nothing, I'll start over, close without saving. So the code opens and it sits here. It has nothing in it. It has this drawdown window, and it has Aster, a funny little blue thing. I can't even tell what that is actually, but that's the meshing thing. This is what we'll use as a post-processing. The rest of these we're not going to use, but some of them have good implications if you get further. So our goal will be, and they really should change this to a creator geometry or load it. We can draw it in SolidWorks and load it straight in here. And then when we load it, we go to the meshing, so we'll mesh it. In this process, we break things apart, and these two processes will break things apart over the boundaries. Then we go back over to here, and I don't know why this one's not over here, but we go here and solve the solution. Then we go over here and load it and plot it. So we got the same sequence, just in a funny order, as the MATLAB code, in that you had to generate your body, a beam or square. You had to put a grid on it. You had to also put boundary conditions in MATLAB. You did the geometry, boundary conditions, mass, solution. And this one is a little bit different. You have to do your geometry and break things out of your geometry for your boundary conditions. Then you go and you mesh it, you include those surfaces, then you send it over here, solve it, and then you plot. So I'll do a simple one so we can get through the whole thing in just a few minutes. Simplest thing I could think of is a box. So here I'll start with my geometry. And of course there's a box. So I'll do a box. Maybe I want to turn it into a beam maybe. So maybe here I'll draw. I'm using the mouse wheel to change its dimensions. I could maybe make it skinny and then run it out here a little bit. Of course, this is a pretty big beam. Let's make it thinner, maybe a little flatter. That's probably okay. You know, good enough, I guess. Okay, so it's the simplest. This is about the simplest thing I could think of. It's essentially a box. There are 6 sides to it, 6 surfaces you could load it or hold it, and that's what you're essentially looking at. Now, you can go in here and create all sorts of complicated geometry, but that's not the point of this first run through it. So the first run through it, we'll look at it. It's a box. That's it. Now, we might want to create new entities by exploding it. Now, here's what you have to be careful of. If I go in and try to explode that, it says the main object is OY. The only way I can reduce it down is make vertices out of it.
So what I'm saying is I have highlighted what looks like a line. The reduction of a line is 2 points. Okay? It calls it a vertex, so I can have 2 vertices. So I don't need to do that on that object.
What you notice is I don't want to do that. I'll select this, go back and select. So now I'm looking at the box. Now look at all the choices I've got.
I've got a shell, which a shell consists of, you have to remember, the box is a solid right now in the code. That looks the same. You can break apart a shell. A shell is simply a collection of faces. It has no bottom to it. It's just all the faces together. But you don't want that. You want all the faces broken apart. So we're going to do faces. Now, what wires are is, think about it, a wire is, you know, in order to look at the edge of one of the faces, I draw a line around that and back to itself. And that's what he calls a wire. It's like a collection of a bunch of segments that move around. They don't have to close on themselves. They can just move like that. Now, a wire, you might want to extrude something down a wire path. But a wire is basically that. Now, to go to a wire, you go down one step, and it's just a segment or an edge. And then you get the vertices, which is pop, you know. So you can break this thing, and I'll show you
what you can do. Here, I'll break it into vertices. And what you see, did I put the button? Okay, push. Okay, so I get a bunch of vertices. What makes sense, there are 8 points, and if you look real close at that, you can get rid of it, and you can see all the points.
That's not what I want. I don't need that, so I'm going to delete all of it. Now, the convenient thing is
I can just go in here and say, I don't want those things. I'll just hit that, and then the delete key. Do you really want to delete the 8 objects? Sure, I didn't want them to begin with. Look back at my box, and I'll explode it again. But this time, I don't want it in shells. I want it on faces. Okay, so I got 6 faces. That's 6 sides to a box. It wouldn't matter if it was a cube or a rectangle.
it just, you know, this is convenient for us because we're going to load, what we're going to do is load the top of it and shut it down, and we're going to hold the back of it. And that way it'll become like a cantilever. So what I need to do is I need to figure out what face is what there.
So what you can do is go to face 1, and then you can right click and you can say, I only want to show face 1. Oh, that's going to be, now what you do is you either double click it and type, just to help, I can name them anything I want, but I need to name them something that I can remember. So I'm naming this one fixed. It's going to be fixed to the wall. So you go to this one. Oh, that one's going to be free. Free means, no, to me, means I'm not going to load it. It's just sitting out there in space like the desktop or the floor here. There's nobody pushing on it right now. So I was simply going through the collection. Okay, that it showed up on the bottom. You might have to, okay, so there is the bottom. I want that one to be free. Okay, let's see what I got now. Oh, that's the top one. So let's make that a load. Okay, now I'm losing track. That is the back one, so that's a free. I don't know why I'm saying this because they're all free now. And the last face should be the one out there, yeah. Okay. So I'm only doing that because I know you have to get these, whatever surface it is. Now this is a constraint of the structure he has in doing this. You can put point loads on these things, but for right now we're just going to put them on a surface. And so you'll see in a minute why we do it this particular way. So I got a fixed, free, and a load. So I only have 3 types of boundary conditions. So then I'm basically saying, oh, all right, I'm done. Okay, so essentially what we did, we created a geometry, then we went back, we exploded into all its faces, and then named them the way that would help us remember in the next step what we're going to do. So that's our goal. So the next thing we need to do is move on to the mesh thing. What happens, it sort of changes color, and there's nothing there. And I've got that box one selected. So there's a couple ways you can do it. You can right-click here, or you can go up and look in this. And what you'll see is the items in that menu. Once you learn what they are, you look at this icon. It says Create Mesh. Well, that icon right there is the same as this one. So all these are here to explain, but they're also, once you get used to the code, they're all laid out here as far as buttons. So it helps you because if you're new to the code like I was not too long ago, I was like, okay, what do I do next? I go to Mesh, I create a mesh. Takes a second, and he says, oh, you want to use the geometry of box. You got to name this thing Mesh 1, and your mesh type is any, and you're in 3D. So he recognizes I selected a 3D. Now watch. If I move to the fixed, which I don't know if I can. Come on. Maybe we won't worry about that. Uh-oh. I did. Notice he moved to the 2D. He doesn't even, you can't even select 3D. He looked back at that and said, you're selecting a surface. Okay, come on. Come on. It's a virtual machine, so it sometimes doesn't listen. Okay, I'm back at the box. Now I go in. The best thing to do, I found, is a thing called NetGen. The NetGen 1D, 2D, 3D. And the reason being is because I have found it's one of the most controllable. Some of the other modules don't work as well. That one tends to work all the time well. And so for that reason, I like to use it because I don't like to have to mess with too much. I like to go ahead and do it and get done with it. Once you do it, the next thing is the hypothesis. Now, what I do is I go and hit this little gear-looking thing, and I do 3D parameters. Now, what you see is you'll see in this the ability to control things. You can make this anything you want. The maximum size, you can reduce that to get more resolution. You can change the fineness. You can make it second order, which we won't do that right now. We'll look at that later. And these are growth rate means, if you got an element that's this big, the next one can't be a certain percentage different in size. So it's the rate of growth from element to element. You don't want one this big, and then the next one this big. You want it to be bigger. So you want some things like that. So sometimes, it's probably good to hold the defaults first, hit apply and close. Now what happens is no mesh showed up yet. But you see a kind of tiny little exclamation point right there that's being highlighted. And let me show you a couple things here before I hit generate. Okay, so you got a hypothesis, you got algorithms, and you got the mesh. Okay, in the applied hypothesis, it's picked up this one. You could have changed that to any name you wanted to. And then the applied algorithms is the one that's pointing back up to. So these parts are independent, which means if I wanted to change the parameter, I can edit the hypothesis and bring that back up. So I can refine the mesh off of that. But I don't have a mesh yet. So what do? I go up to mesh and compute. That little wheel is the compute.
And you'll eventually realize, oh, those are all laid out there. And so you can change that. So I just hit compute. Then a little thing comes up, and boom, there's my mesh. It tells me I have 105 nodes, 200 faces, 64 edges, 225 volumes, which are essentially elements. And there's the picture of it. You can hold your control key down, left mouse button, right mouse button. I'm sorry, that was the middle mouse button. And then the right mouse button. So you can look around at it and you can say, well, yeah, it looks like a mesh to me. Looks good, everything's good, looks like a bar. Okay, so the thing is I haven't, to this, at this particular juncture, it looks at it and says, that's great, but I have no surfaces on it. I need to identify what's the surface. So what you do, I still have mesh selected right there, so you sort of select mesh. You go back up here, and you do create groups from geometry. Now, he is selected, you've selected mesh 1 before you did anything. He has this button kind of highlighted. He wants you to select some geometries. So you can just select all those things and hit apply and close. What you see is he'll say groups of faces. So here you can look at that, do whatever you want. Let's see. Now wait a minute. The bar moved over. Hang on. If I slide it over a little bit, I can unselect that so you don't see it. And then all of a sudden, I can see there's a fixed. You see that little thing show up on the right there? So there's your fixed. There's a free. There's where I'm going to load it. So I'm going to push on the top right here. Now you notice they're all the same color, but if you don't like that, say you want the fixed to be, let's see. There's a way. Oh, somewhere. Anyway, somewhere in there, there's a place you can do the color off of it. I can't. Okay. Display entity. Choose. No. Mesh quality. Mesh information. Maybe it's mesh. Nope. Not information. Nope. Anyway, somewhere you can change the color of these. Oh, there it is. So you can change your color right here. So if you want, no, you don't want it to be black. So you want the blue to be the fixed. Then you see it changes right there. And if you go back and look at the fixed, it looks kind of blue. The same thing applies. Control right mouse rotates around. You can look at it and you can say, okay, there's my fix. That's kind of beneficial if you get something real complicated. You can color all the fixed, color all the free, and color the loaded, and you can kind of see what's loaded and what's fixed and sort of work your way through it. The beauty here compared to SolidWorks is you actually get to see and count and pay attention to the mesh size. You can control it. Sometimes it's a difficult thing, and that can be not so fun at times. Okay, so I think I better save this before I go on, because the last thing is I don't want things to explode on me. Looks like study 1 is taken up, so I'm going to call it Beam 001. Now this is not showing up on Google Drives, but I can put it there later, because this is a system that's self-confined to this. But I'll put it out there later. So your next goal is, what do I do next? I've been through the step where I created the geometry. Then I made some kind of funny mesh, broke the boundary conditions away. And I did just save it. And I always get a little nervous before I do that. But I don't know why. There's probably somebody out there who does, why it's called Aster, but it is called Aster. So there it is, and what you've got is you've got a linear elastic, which is kind of where we're going to stick to for the time being. Modal analysis, which is a vibrational thing.
Linear, so if you want to get involved in heat transfer that changes the stress, like what's it called? Thermal stresses like stuff. And then it's crack analysis. Now, crack analysis is kind of nice. It's like what we will find out is that if you have a chime line or a chime point, it's a stress concentration. And that always occurs in a structure. So this sometimes is helpful if you want to, but we're probably not going to cover that in here. So I need to select my mesh and say linear elastic. Okay, what kind of model do you want to work on? 3D. I wonder, I've never messed with anything else. Plane stress, plane strain. Hey, there you go. So I guess you could do it on a 2D surface. Next, select a mesh from the Salome object browser. And I guess I have to do that. And you have two choices here.
And I feel uncomfortable about one only because I already moved the geometry surfaces into the faces in the mesh. So apparently you can use geometrical groups, which are back up there, or you could use mesh groups, which I did. So I kind of like to do these. I have not even done the other one because I kind of feel like I would like to separate the process and keep them separate.
So if I go in and say, I'm going to use the mesh groups, and he says next, now you get your Young's modulus. Now,
it is, if you notice, that all he says is he says, well, the modulus has to be greater than 0. Okay, that makes sense. And then he says that the Poisson's ratio has to be, he says, between -1 and 1/2. Half is incompressible stuff, which can cause some issues. But most of these days they work around that pretty easily. Looks like that's the default, which is
2e to the 11th. So that's probably, in France they used SI units. But you notice there are no units here. And you notice when I drew it, it didn't have units. I just drew it out there. The beam was like 300 long and all that stuff. So the units are incumbent upon you to figure out what they are. So you have to be careful about that. Although Poisson's ratio, you don't have to worry about. So hit that, and now he says, add the imposed degree of freedoms on the groups. Boundary conditions. I can do this and add something else, and then what you find out, okay, hang on. Or you can look at the different ones. So the displacement at XYZ, then I got some sort of add pressure. So, okay, now let me
separate two parts of it. Aster is an independent code that sits over here. It has a lot of capabilities, far more than what we see in this pop-up menu. If you go over to this is a communication code between your file and creates an Aster file. So the fact that he says there's only pressure boundary conditions is only because this little pop-up is not allowing you to input a shear boundary or even a contact. Aster has the ability to do contact. Now contact is a hard thing. It's like you take a soft object and you push on something. You're deflecting both my hand and the table at the same time. And so when you're doing that, when you're doing both, you need to calculate both. And there could be a friction, it could be all sorts of stuff. So Aster has the capability of doing, I don't know if this is right, but I think there were 4 different friction models. Which if you get involved in fine elements, that's where a lot of them break down. And apparently they've solved that here, but it takes a lot to get into that. And if you want to get into that further, there are different types. We could look at that, but you'll have to learn French. And when you do, I'd like to teach you French, so I can read. So, but right now it allows me to do it deeper. So he's got just pressure, and that's all he has.
So he has that, and I need to do, and I don't know if I can do all of them. Can I do all, or am I going to have to do each one. Now, see, I need to do this one. That's the load. Okay. I looks like I'm going to have to do each one. I give it 0. I'm not going to do anything there. Okay. Luckily, I can drag this down. Okay, how many frees do I have? 1, 2, 3, 4. I should have actually numbered those now. 1, 2, 3, 4. Now, the problem is I don't know which free I'm looking at. So what I'll do is I'll say there's the first free. There's the second free. I don't know. I should have done this differently. There's a third free. I think that's the fourth free. Now, if I didn't goof up, man, now I think about this, I should have done it the other way. Uh-oh. Uh-oh. Maybe they're all that way. Well, I'm just going to go with it. If necessary, I may have to come back and rename those. But, okay. They don't have a load on them. There's nothing happening. Now here, you have to create some kind of file. Now this is a command file that's used to run Aster, and I don't know what to call it. Beam 00001. How about that? Is that a good name? And then you go finish. And then it swirls around. And you look down here, there's a little bitty, in this object browser, there's a little bitty thing, real tiny. It says linear static. It says data. And it has, okay, let me drag down. It has all this, all this stuff. And you look at it and you're like, oh my gosh, look at this mess. Well, luckily, at this particular point, I don't have to worry too much about it because he's got this little funny thing up there, and I hadn't run the analysis yet. So he tells me, oh, there's a submit script, build script, all this stuff. You'll see what happens here in a second. So I go up here, select it, and then hit that button, and a little window will show up somewhere. There it is. And see, this one is a small one, so it ran pretty quick. Uh-oh, ended up with a failure. Uh-oh, you know what? It may have been dealt with my free things. You know what? I better go back here and rename these things. But you know what? I may have to delete my linear static. I'm not going to go try to fix that. So here's what I'm going to do. Free. How about just F1, F2, F3, F4. Now, I'm still a little bit worried, so first thing I'm going to do is go delete this. Delete, goes away. The Aster thing's still there. I'm still in Aster, but I really need to move back to the mesh because I want to double check myself. Free. Okay, I think I'm okay. So I got F1, 2, 3, 4. So, and there are things like this that you'll find along the way. There's nothing perfect. There's my mesh. Go back over here. Okay, it's thinking about it. There it is. Start it again. Yes, I'm going to do a 3D. Yes, did I select that? Yes, I like that mesh. I want to use mesh groups. I'm fine with that. I don't really care. That's where I'm going to fix it. Okay. Here's where I need to put my load. 1, 2, 3, 4. I guess I could do loads on all that, but I don't know why I'd want to. Sometimes it's a little slow or hard to figure out what it's doing. Okay, next. I think I got that F1, F2, F3, F4. F1, F2, F3, F4. Okay, you know, I think he may not let me use that same file, but he might. Maybe he did. Okay. Now, let's cross our fingers and our toes and every hair we have on our head. Success! Yes! Let's dance around. Ended with the status success. If there is a med files route, you can import it manually. Result to this what's called Paraviz. Now, just to give you a historical component of that, let me show you something. Okay, before I launch this Paraviz, because I got a few minutes. Well, this is embarrassing. Okay, here. Let's look at this. Paraview. This is what Paraviz is. Sounds weird. Okay, so Paraview is available for download. You can download it for free. You can see that little icon. Look at this icon right there and that. They're essentially the same thing. It's very very generic, so to speak. But let me see if I can find a couple of examples. Gallery. It's pretty amazing the stuff you can get for free. So, electronic wake of an energy recovery line. Let's take a look. What does that mean? Okay, so take a look at.
This is for free. This was developed. Okay. I know I'm being recorded, but I think it was at San Diego. But I might be wrong. Somewhere out in the national labs, they did a contract and they fulfilled it. The nice feature of this is that, let's say you had just a massive data, billions of points, not millions, but billions. And then you string all these computers together on a high-speed network. And I sat here, it can, if you set it up right, use each processor to generate a block and do the visualization. So it's a nice product in that you can use it like little old me can use it, and I don't have to do that complexity. And you can, obviously, these guys have used it, moved it over to France, did it a little bit, put it inside Sloan. So you can do that. But you don't have to do it in parallel. And the sequence that what you would do would be the same. It's just that you would load things off of the processors and stuff. But you can see it's not, if you had to pay for this, you'd pay a lot of money. And it's got quite a bit of capability. And there's a lot of dynamics that you can see out of it. I don't even know what that was I just looked at. This looks like a turbine. You know, a movement of flow lines inside of a turbine. So just to let you know, you're not really you're not downloading some product that some guy that sat there for a week developed. This was a lot of man hours. And there's a large free support group for people out there if you want to use this kind of stuff. So with that, here, there's a CFD around a race car looking thing. There's a VSTOL aircraft with, looks like some air coming at the aircraft. So, front view of it. Oh, side view again. I didn't notice that. CFD UFO. There's a wing, just pressure and shock. Oh, there's some turbulence coming off of a object, which I don't know what that object is. So this is not like a piece of junk you would download. Now, what happened is they put it inside here, so I can go in it and start it. Let it come up, and then I'm going to sort of move because you need a little bit more space. Come on. Okay, come on there. I need a little bit more space over here. So what you see, this is exactly what you would see if you just do Paraview. It just so happens that what they did is they focused Paraview for reading these codes in, and it's sort of set. It's basically picking up the local host. You can do open. Down here, there's the linear static. Give it a second, and all of a sudden it's there. Now, here's one of the things. You've still got those little eyeballs, and those eyeballs appear on the regular Paraview as well. But you have this, you can load stuff, but you have to hit apply, and there's your object. Now the thing is here you don't have to use the control key to rotate around. See, the middle mouse button makes it go bigger or smaller. Right mouse button does the same thing. Left mouse button rotates. So you can look in this at what he has done is he has pre-made this so that, you see this and you're like, what is that got to do? Well, this is the result, the displacement, the sigma q, and I think this is the von Mises stress, this lower one, but we'll address those later. But right now, I sort of want to look at what the displacement looked like and hope that it looks reasonable. Okay, so one of the things you can do is you can say, so you see this minus sign, you can do that, and you'll see that it comes up with, this is the newer version. Before it had those and you couldn't shrink them. Now it has the properties, the display, and the view. So let's go into each one of these and see what it is that we might be interested in doing. The view, there's usually not much to do there. You could change the background color. If you're doing a presentation and you don't like that color, whatever color this is, which it looks like a bluish gray, you can change that. It's something else. You can do a stereo render. That's it. To make it 3D, so those 3D glasses, you can make 3D images so we can all sit around with 3D glasses and look at it. This is, I think you can make your, let's see if I can make it. It may show up, and it may be hidden inside the body. So the axis visibility is that thing. So you see that little axis that disappears? Oh, look at that. There's the stereo rendering. That makes my eyes spin. So I like to keep that out so I can see it. So there's not much to happen there. But here's what you can do. You can say, well, I want to see what the displacement magnitude looks like. And what it did, I colored the surface of the thing by the displacement magnitude. I showed now this is the default, I showed the color bar, which might interfere with you. So you might want to move it, and I believe, if I'm not mistaken, you can just get it out of the way, move it up here, okay, it's going to be out of the way now. So now you can move around. You can see the displacement isn't very much, because I think I just loaded it with one. I had a beam that was 300 units long, loaded it with 1 unit of force across the top, which is 1 pressure. My modulus was 10 to the 12th or something like that. It's a pretty stiff beam, so it's not going to deflect that much, and it's not going to have that much stress. But it doesn't matter. Now if I look, I can look at that. So here's your stresses, and it looks to me like when I do that, it puts the thing back down here. So there's my stress magnitude, 3.9. So I should look more to get more of the stress out. But you notice the 3.9 occurs around the top and the bottom. If your beams that you kind of notice, maybe see overlap. So usually your stresses are the highest at the top and the bottom, unless you have some other funny logo. But you see this little wiggledy here. That's because it's not refined enough. So we're going to go through convergent studies off of this as well. But this is all good. And they got properties. Usually you don't need to mess with that, because it's when you're loading that Aster file, it sort of does this part for you, so you don't have to search it out. So I would leave that one alone. Now the cool thing is you go up here, and let's see if I can find the, hang on, view. I gotta find my, or did it put, wait a minute, I'm looking for my, there's one other window, let's see if I can find it. On my other one, it was out there. I need to, maybe it was over the view, Windows. Okay, now I got to figure out which one it was. Well, I guess what I could do, I'm pretty sure it's not the Python cut. It's not that. So I'm going to have to go through here and get the right window. Oh, wait a minute. There's your object browser. I don't need the object browser. So let me get rid of that. So you're going to have to bear with me as I go through this. Nah, I don't need the display. What about view? No, I don't need that view. Actually, the display and the view were the ones that I hid off of there.
I need the, it's not animation, statistics inspector, no. Hey, wait a minute. It might be up there. Multi-block inspector, nope. I don't need that. So, comparative view inspector, nope, don't need that. Yeah, let me get rid of that. But you know what? I'm wondering if it's hiding behind the others. Okay, let's see. That's the time. Let me just break that out. Huh. Well, I need to do one thing to this. Okay. Bang. I guess I could do it off of the browser if I could find it. Let's see. Tools. Let's see. Record test match plugins. Let's. Nope. Okay, there. We're G. Do you see the letter G? Oh, there. Now it's a 2D gun. Let's see what happens if I do that. That's a 2D. That's not what I need. Trying to find my the modes are. Oh, there you go. That's not exactly what I wanted to have happen. But the modes are modal shapes in case you want to do dynamics. But embedded in that, I can let that go while I keep searching. What I'm searching for is, let's see, I'm getting this thing all mixed up. Look at it. There is a set 3D glimpse. Okay, well, I'll just do this. So I enter to search. I didn't search for anything there, did I? Oh, I can't do a 3D glimpse on that. There. Now that's a good one. Nope, don't want to do that. I'm looking for, let me go back into filters. It's wanting me to do that, but maybe I need to just go through this and find, there they are. Okay. Oops, I missed them. Common, and go down to this glimpse, and it'll move it. Oops, it pushed it to the side. I think I better stop this thing. So let's just do a delete. We'll do a delete here. Delete. We'll do a delete here. We'll do a delete here. And then I'll go back into there. Common. Common. There. Now, it may not look like much is happening. And it certainly isn't until I come in. Let's see. Oh, wait a minute. Wait. Go back in. Filters. Common. Oh, I did the wrong one. Warp by vector. That's what I want to do. Now get rid of the glimp. Delete that. Now come back here. Close that. Hit apply. It doesn't look like much happened until I go in here and you look at it. I guess coloring it by that's fine. Properties. I might want to scale it. Now, the deflections weren't very high. So if I'm going to vector it, you'll notice, all right, see what you notice is, let's see, let me open the original, and then I'll go back into the original. I will display it, but I will make it quite opaque. And so what you have from this is, by looking at this warp by vector, what you've done, I don't know if you can see that. Really what happened is there's supposed to be another ribbon up there that has these, and then we're used to hitting it off that, but I guess this is fine. The original configuration was this opaque structure. After it deformed, this is a deformation, so it got deformed by this and that. In this, see, a lot of this is left up to you. In a lot of software, this is the reason I like it. A lot of software will do stuff just like what the map does. You look at the deflection and you think, oh, the deflection at B is 5. And then you put more elements, the deflection of that quadruple, but it still looked like the same shape. What happened is it decided to scale the plot for you. It didn't give you that chance. Here, it's all up to you. It comes in and you want a scale. Well, here, let me go back and go to here, and I'll color it by the deflection. And now I'll go back to this and color it by the deflection as well. What you see is, obviously, okay, what I see with glasses is that at the very right, it's 1.4 times 10 to the, if you think it's -7. Over here, it's blue and it's almost 0. I have a feeling at the very left, that's the back wall, that's 0. So on the top we showed this thing, well, it didn't deflect that much. So if I put it, this thing was 300 units long, and it's deflecting 1.4 times 10 to the 7. Well, what that means, here, that means if I made that 1, yes, that thing deflected to me. Oh, I ain't got to hit the apply button. Then yes, if you zoomed right in, there would be 2 solids. One would be, here, one would be down 1 times 10 to the -7. So the scale factor of the deflection is 1, meaning it's exactly what it looked like. That's not giving you a good visual. So you could say, hey, wait a minute. Let me make it 100. Do I see anything? No, still I don't see anything. 10,000. Nope, still don't see anything. Don't see any. Make it a little bit bigger. Don't see it. Uh-oh, now you see it for the first time. A little bitty deflection. Now you see it. And what is it? 100 million. So I made the scale 100 million in order for me to physically see it. Now, what that does is that gives you, it's like playing in the mud in a way. If you play in the mud and you get off your hands all dirty, you see what's going on. If it removes you from that process, it just gives you a picture. If you look at it, you might get the impression that the deflection was in fact a certain level, like when you're fooled into thinking inside the macro code. But this is not done that way. This is raw, straight sent at you. You have to determine. So you'll get a feel. You look at that. Well, I had to multiply that times 100,000 to get it. I know 100 million to get it to look this way. Well, that's because of the displacement. The largest one was 1 times 10 to the minus 1.4 times 10 to the minus 7. So it didn't deflect that much. So in essence, this is one of the interesting things here. Now there's a lot of other things you can do too. You can go in here and you can go to the filter. Oh, I should freeze it. Okay. So apparently I think it's time for class to end. So what I'll do, I can stop us right here. The cool thing is I can just go like this. I can save the machine state, and when we start lectures on Monday, I can pick this exactly up where I was. Okay, now where's my thing? There it is.